So section 11 is on the product and quotient rules. Okay, so we're going to start out with a very basic example so you can see why we need the product rule and why we need the quotient rule. So it says, is the derivative of x times x squared, is that the same as taking the derivative of just x and then the derivative of x squared? So let's think about this. If I have the derivative of x times x squared, right, that's going to be x cubed. Is that going to be the same as the derivative of each thing? So if I take the derivative of x, I get 1. The derivative of x squared is 2x. What is the derivative of x cubed? 3x squared. Is that the same as 1 times 2x? No, it is not. So if you're checking to see if they're the same, they clearly are not. Okay. It's kind of like if you had like x to the 10th, you can't break it into x times x times x times x 10 times, right? Because when you take the derivative of each thing, it would just be 1 times 1 times 1 times 1. So we clearly need some kind of rule for when we have the product. Okay. So we use what we call the product rule. So it says if f and g are both differentiable, then the derivative of f of x times g of x is going to be f prime of x times g of x plus f of x times g prime of x. Okay, so we take the derivative of one and we multiply by the normal function of the other, and then we switch them. Okay, derivative of the other, normal for the other one. All right, that's a pretty easy formula. And sometimes I'll write this backwards. Sometimes I won't do f prime first, instead I'll do f of x. It doesn't matter because there's a plus between, right? So I can write it in any order as long as I have the derivative of one and the non-derivative of the other. Okay, the quotient rule is a little bit harder, right? This is what the quotient rule looks like. There's a saying that goes with it. So I'm going to say the saying as I write it. So the saying is low d high minus high d low all over the square of what's below. Don't you like that saying? Someone asked me if I came up with it. No, it's been around for a really, really long time. All right, so here we go. So low d high minus high d low. So whenever you're saying d whatever, it's the derivative, all over the square of what's below. So we take g of x and we square it. So we took low, meaning we took the g of x function that was on the bottom. So then we did d high minus high, derivative of low, all over the square of what's below. All right, that one helps you keep track of what comes first. So it always starts with the low part. It starts with the denominator. Okay? All right, so it says find the derivative of the following functions. So if I have f of x equals 3x minus 2 times 4x to the fifth minus 10, we're going to go ahead and try to use the product rule. Okay? So if I'm using the product rule, what I'm saying is that I have one function times another function, right? And it's set up so I can see my parentheses. So I'm going to take the derivative of the first one. So the derivative of 3x minus 2 is just 3. And then I keep the second one normal, so 4x to the fifth minus 10. And I have plus the first one normal, so 3x minus 2. And then the derivative of the second one. So I get 20x to the fourth. And I simplify, so I'm going to multiply the 3 in. So I get 12x to the fifth minus 30 plus 60x to the fifth minus 40x to the fourth. And I combine my like terms. So I get 72x to the fifth minus 40x to the fourth minus 30. Okay, what do you think? Do you think that was easier than foiling out or harder? The foiling is actually easier. Okay, this is not why the product rule was invented for things like this. So I could do this another way. So I could FOIL first. So I could say, okay, well, f of x is really, if I FOIL it out, I get 12x to the sixth minus 8x to the fifth minus 30x plus 20. So now when I take f prime of x, I get 72x to the fifth minus 40x to the fourth minus 30. It was 2 steps, right? Much easier. So sometimes multiplying things out is easier. So I always want you to use your best judgment on your homework. Okay, if you're doing something that takes a lot of time, like maybe you're not doing the right thing. Okay, so this would be easier if you just kind of FOILed out. The reason the product rule is useful is for things like x squared times sine of x. Okay, we don't know how to take the derivative of x squared sine of x together. We haven't learned a rule for that. Okay, so what we would do is we take the derivative of x squared, multiply by sine of x, right, plus x squared times the derivative of sine of x, which we're getting ready to learn in just a bit. Okay? All right, so number 2. So you can do either way. Let's go ahead and use the product rule since we're trying to get used to using the product rule, right? So let's say f prime of x equals the derivative of the first is 12x cubed minus 12x. The second one, normal, is 3x cubed plus 1. And I'm going to have plus, the first one, normal, is 3x to the fourth minus 6x squared plus 7. And then the next one's going to be 9x squared. That's the derivative of the second. And we simplify. So we start FOILing out. We get 36x to the 6th plus 12x cubed minus 36x cubed. Did I make a mistake? I feel like these numbers are not the same as what I had from yesterday. Am I good? All right, plus 27x to the 6th minus 54x to the 4th plus 63x squared. All right, so what do we get? So we're going to combine our x to the 6th. 63, is that right? 63x to the 6th. And then we have no x to the 5th and x to the 4th, so minus 54, x to the 4th. I really do feel like I did something wrong. It's minus what?
36x to the 4th at the top.
Yeah. Okay, hang on. Let me go through my original. So f prime of x is 12x cubed minus 12x. Do you agree with that?
On the first row of your answer, it's 36x to the 6th plus 12x cubed minus 36x to the 4th.
Okay, this should be a 4th.
Yeah.
That should be x to the 4th.
Yeah.
And then what was it after that? So
Minus
okay, minus 12x. Okay, thank you. All right, so what do we get? So we have x to the 6th. So we still do have 63. Yeah, so we're going to have 63x to the 6th. And then we have minus 36x to the 4th minus 54x to the 4th. So minus negative 90x to the 4th. I still feel like these aren't the right numbers because I'm a freak and I memorize numbers. All right, but we'll go with it. All right, and then we have minus 12x cubed minus 12x plus 63x.
It's positive.
Plus 12x. Which one's? Okay, hang on. The cube. So plus 12x cubed minus 12x, like that. I still feel like
it's not 63x squared.
Okay, I'm starting this problem all the way over. Sorry that I'm recording a video for this. My YouTube viewers are going to be like, what? All right, here we go. F prime of x. I'm taking the derivative of the first. So I get 12x cubed minus 12x. I keep the second one normal. 3x cubed plus 1. I do the second one the same. 3x to the 4th minus 6x squared plus 7. I take the derivative of the second one, 9x squared. All right, I FOIL. So I get 36x to the 6th plus 12x cubed minus 36x to the 4th minus 12x plus 27x to the 6th minus 54x to the 4th plus 63x squared. So when I clean it up, I get 36 plus 27. So when I combine those, what do I get? 63 x to the 6th. And then I have no x to the 5th. I have an x to the 4th, so I have minus 36 x to the 4th minus 54 x to the 4th. So I get minus 90 x to the 4th plus 12x cubed minus 12x. Did I have the x squared? I did not. So plus 63x squared minus 12x. Are we good?
Yes.
All right. Sure. I still feel like those are not the same numbers I had in yesterday's class. So maybe I just did yesterday's class wrong. All right, here we go. So anyway, so f of x. So f of x is now a quotient. Okay, this is not one. Like if I had something like 3x squared minus 6 over 4x cubed, would you use the quotient rule for that?
Of course.
You would not. You just did this on yesterday's homework. What would you do instead if you just had a monomial on the bottom?
You separate.
Yeah, you'd separate it. You would write it as 3/4 x to the negative 1 minus 3 over 2 x to the negative 3, and then you would take the derivative, right? So don't forget the basics. That's what everybody always does. As soon as I teach the quotient rule, they just want to use the quotient rule all the time, right? Don't forget how we did that with power rule. All right, so this one we can't do that because we don't have a monomial on the bottom. We have that whole 4x cubed minus x plus 6. Okay, so what we're going to do is we're going to do low. So the low is the denominator. So low, d high. So when I say d high, what I mean is the derivative of the part on top. So d high is going to be 6x minus high, so 3x squared minus 6, d low. So d low is going to be 12x squared minus 1. All over the square of what's below. So I'm going to do 4x cubed minus x plus 6. I usually just leave the bottom as something squared. I don't really FOIL that out. All right, and I simplify. So I get 24x to the 4th minus 6x squared plus 36x. And I have minus, and I'm going to put a bracket so I know I'm subtracting out that entire product. So I'm going to have 36x to the 4th minus 3x squared, and then I'm also going to have a minus 72x squared, so I'm going to write minus 75x squared plus 6. I think these are the numbers I was remembering from before, so maybe that's why. All right, so get this. All right, so as I'm combining, I have 24x to the 4th, and I end up distributing the negative, right? So I get 24 minus 36. So I get negative 12x to the 4th. And then I have negative 6 plus 75, so plus 69x squared. 36, that's all by itself, so plus 36x, and then minus 6, all over the denominator. All right, that's our answer. No. Yeah, don't factor. All right. So let's do it again for number 4. So number 4, so I'm going to have f prime of x equals low, so x cubed minus 1. D high is 14x minus 5 minus high. D low is 3x squared. I do this a lot in calculus where I have to do a double, like a double numerator, a stacked numerator here, all over the square of what's below. So x cubed minus 1 squared. So I continue to simplify. So I'm going to FOIL out. So when I do that, I get 14x to the 4th minus 5x cubed minus 14x plus 5 minus, I'm going to put parentheses, 21x to the 4th minus 15x cubed, all over x cubed minus 1 squared. Sometimes if I get lazy and I'm doing a really long quotient rule problem, what I'll do for the denominator is I'll kind of put like little quote marks instead of writing it. So I'm fine with that on your homework if you guys do that, because it does get annoying writing the denominator every single time, and you don't want to forget it. All right, so then we get equals, so I have 14x to the 4th minus 21x to the 4th, so I'm going to have negative 7x to the 4th. I'm going to have negative 5x cubed, but I'm going to distribute that negative to give positive 15x cubed. So I'm going to have plus 10x cubed minus 14x plus 5 all over x cubed minus 1 squared. That is your answer. So like I was saying, choose your battles. So like on number 2, I had a hard time with that, right? Even I had trouble using the product rule just because it was a lot. So it probably would have been easier since I was going to have to FOIL. Right, see, I was FOILing anyway here. I might as well multiply it out first and then take the derivative. It's just easier. Okay, so choose your battle. And remember, like I said, if you see that you have a monomial on the bottom, always do the thing that we did in the last section. So break it apart and then use the power rule. Okay, so if you just have one term on the bottom, do not use the product rule. This includes some of my students, like when I have this, like even something like that, like just a 2 on the bottom, they think, oh, I have to use the quotient rule, right? You don't have to use the quotient rule on that, right? It's 5 over 2x minus 2, right? Then take the derivative. The derivative is 5 over 2. I can do it all in my head. No quotient rule, right? All right, so here we go. So it says find the second derivative of the function. So again, this is one like the power rule that we did yesterday, 2 days ago. So I'm going to rewrite. So I'm going to write it as x to the 1/2 minus 4x to the 1/3 plus 6/5 x to the negative 1/4. Okay, so I rewrite it. So now when I find f prime of x, I do 1/2 x to the negative 1/2. Then I have negative 4 times 1/3, so I'm going to have minus 4 over 3 x to the negative 2/3. And then I have 6/5 times negative 1/4. So I get negative 3 over 10 x to the negative 5/4. That is the first derivative. So the first derivative would tell us information about the slope. All right, now we have the second derivative. Okay, so what do you think I do for the second derivative? I just go again, do it again, right? And the way that we write this is f double prime of x. So we read that as double prime. Okay, if we had the third derivative, we would write triple prime. But then we don't say quadruple prime, we just say the fourth derivative. All right, so here we go. So now we take the derivative again. So the negative 1/2 multiplies by 1/2, so I get negative 1/4 x to the, subtract 1 from the power, negative 3 over 2. Plus negative 4 over 3 times negative 2 over 3 becomes 8 over 3 x to the negative 5 over 3. And then I have negative 3 over 10 times negative 5 over 4. So there's going to be a little bit of reducing.
I believe it's 8 over 9.
Oh, did I say 8 over 9 and right or wrong? 8 over 9. Oh, I said the wrong thing. Thank you. All right, so this and this cancel. So I get negative 1 and a 2. So I get 3 over 8. So I get 3 over 8 x to the negative, no, wait, is that right? 9/4, yeah. Subtract 1 from the power. So minus 4 over 4. All right, and that's our second derivative. Okay, now what the second derivative will end up telling us is something called concavity. So let me kind of draw a little rough sketch because people in the other class were asking about this. So the first derivative tells us about the slope. So it tells us where we're increasing, right, going up, and where we're decreasing, going down, right? The second derivative tells us where it is bending upwards and downwards. So right here, see how it's pointed downwards? And then like from here to here, it's going upwards. They call that concave up, concave down. Some books will say holding water, like where you can hold water is concave up, where you can't hold water is concave down. But that definition doesn't always work because if you have x cubed, right, we call it concave up, where x is greater than 0, but concave down here. Do you guys see how it's like bending up or bending down? Okay, so that's what it tells us. So basically with concavity and with the first derivative, so first and second derivative, you're able to graph any polynomial. So you and actually rational functions too, like things with denominators. We can graph anything using calculus by hand. We don't have to use calculators. We will know what every single thing looks like. And that point where it changes, that's important in the business world. So right here. So see how you're increasing there, you're going up there, but all of a sudden it's changing in concavity. That's called the point of inflection. So it changes from concave up to concave down. So that's what we call the point of diminishing return. Okay, has anybody heard of that in econ? You guys probably aren't that far into econ yet. But basically, I don't know, I'm trying to think of like something when I was a kid, like one Christmas, there was a toy called Tickle Me Elmo. Have you guys heard about this?
Oh, no.
And people went nuts, like nuts for Tickle Me Elmo. Like it was all over the news. People were like hurting people in stores to get the Tickle Me Elmo for their kid for Christmas. I mean, it was nuts. And so I guess if you think about any trend, like anything that's super popular, or maybe like housing, you know, like selling houses and so on, maybe things are on the way up. Yes, it's you know, still rising, rising, rising. But all of a sudden, it's not as exciting, right? All of a sudden, things are kind of tapering off. That's the point of diminishing return. Does that make sense? So that's why it's important. Okay, so anyway, so derivatives of sine and cosine. So the derivative of sine, let me write it as d dx. So the derivative of sine of x. Let's see what it is, actually. Let's talk about the slope. So you guys have these curves. You have the sine curve, right? Let's talk about where it's increasing and decreasing. Okay, where does it have a horizontal tangent? Where is the slope equal to 0?
1 and negative.
At the height of 1 and negative 1, right? So at x values of what? Where is sine equal to 0? Or where is sine equal to 1, I guess? Pi over 2 and 3 pi over 2, right? So if I'm graphing the derivative on the same graph, what I'm going to do is I'm going to graph like the slope. I'm going to say, oh, m is equal to 0 at that point. So my y value is going to be 0. And my y value will be 0. So I'm just graphing all of the numbers for slope. All right, right here, the slope is actually equal to 1. And here, the slope is equal to negative 1. So if I connect all these points, I end up getting something like this. What graph did I just draw? Yeah, graph cosine. So the derivative of sine is cosine. All right, but now we want to talk about the derivative of cosine. So again, we start with the places where we have a horizontal tangent. So there, there, and there. So that's where the derivative is equal to 0. So when I graph the derivative, I'm going to graph y equals 0 there. All right, and then let's think about it. So my curve is going down from here. It's decreasing. So when I graph the y values for the points for the derivative, they're all going to be negative, right? Because my slope is negative there. So I'm going to be below the axis, right? And then my slope is increasing. So now I'm going to be above the axis, and so on. You could also talk about where the slope is 1 and negative 1. The slope right here is 1. The slope right here is negative 1. So it should be at negative 1 and positive 1 there. Okay, and that's how you can see it. Is that sine of x? No. So the derivative of cosine is not sine of x. It is negative sine of x, exactly. Okay, and we'll talk more about graphing derivatives. I know that's kind of weird. So, all right, so number 1. So it says, well, what if we have y equals x cubed sine of x? Okay, this is when we have to use the product rule. We cannot like FOIL things out and avoid using the product rule. This is why the product rule was invented. Okay, so when I take the derivative, I'm going to do the derivative of x cubed is 3x squared. I'm going to write parentheses so you guys can see what the first function, second function is. So I'm going to have 3x squared, the derivative, or keep sign normal, so sine of x, plus x cubed, derivative of sine is cosine. So all we do is we write 3x squared sine of x plus x cubed cosine of x. We do nothing else. A lot of people try to bring the 3x squared into the sign. You can't change the argument. That's like the angle, right? You can't multiply a number out front into the angle part. We can't do that, so we leave it like that. You could, I guess, factor out an x squared, but like, what's the point, right? It's not doing anything for you. All right, so f prime of x for the next one. So we do low. D high is 4x cubed minus high. D low, the derivative of sine is cosine, all over the square of what's below. And again, not much you can do to simplify. Okay, so I'm just going to write 4x cubed times sine of x minus, and I'm going to leave it as x to the fourth minus 2 times cosine of x. You could, I guess, multiply that in and have x to the fourth cosine of x, and then plus, I guess, 2 cosine of x. But again, there's no like point to doing that. Like, it's not simplifying it at all. Let's forget that. Now, on your AP test, on the multiple choice section, they could have different things. Okay, so maybe they decide to bring the sine squared x in, right, to both pieces. Well, then you're going to have like cosine of x over sine squared of x. And they might get fancy and say, well, that's going to be cosine over sine times 1 over sine. And cosine over sine, we know, is cotangent. So cotangent x times cosecant x. So be looking for things like that. They can always change it around. It's frustrating, especially the AP test is terrible with that, with the multiple choice. They always put things in different forms, especially with logarithms. So natural log with E and logarithms and so on. They're going to do weird things with this. All right, so here we go. It says in the last section, we said that the derivative of negative powers also use the power rule. So in other words, the derivative of x to the negative 2 was y prime equals negative 2 x to the negative 3. Okay, so let's verify this. Let's see why this is true with the quotient rule. Okay, so let's say we have y is equal to x to the negative 2, which is really the same as 1 over x squared. Okay. So if you had a problem like this on your homework, I would use the power rule, right? I would just take the negative 2 to the front and then do x to the negative 3. It's so much easier. Okay, but you could. It works with the quotient rule. So I would do low d high, the derivative of 1 is 0, minus high d low, all over the square of what's below. And the x squared times 0 goes away because it's just 0. So I get negative 2x over x to the 4th, which reduces down to negative 2 over x cubed. Is that what this is? Yep. Same thing, right? Negative 2 times x to the negative 3 is just negative 2 over x cubed. So same thing. So it says, in fact, we said that n could be any real number when we talked about the power rule. So we didn't talk much about this, but I can have like the square root of 3, right? Then I would pull the square root of 3 to the front, and I would subtract 1 from the square root of 3. It could not only be positive and negative integers, but it could also be rational and irrational numbers. Okay, it could be pi, right? You could have your power as any real number. It doesn't matter. The only thing it can't be is I. Okay. All right, that's not a real number, right? Okay, so with this, so if I have f of x equals x to the 2 pi. So when I do that, I'm going to have f prime of x equals, I pull the 2 pi to the front, and then I do x to what power? Exactly, 2 pi minus 1. A lot of people in the last class said pi. I was like, no, 2 pi minus 1 is not pi. 2 pi minus 1. All right, number 2, this is again something that we did yesterday, so x to the negative 2/5. So I'm going to have y prime equals negative 2/5, x to the negative 7/5. Subtract 1 from the power, so I'm subtracting 5 over 5. Number 3, do I want to do the quotient rule? No, just because it's set up as a quotient doesn't mean you have to use the quotient rule. This one has a monomial on the bottom. So I break it apart. So I do 2 over the square root of t plus 3t over the square root of t. So I have 2 over t to the 1/2 plus 3t over t to the 1/2. So g of t is 2t to the negative 1/2 plus 3t to the positive 1/2, right? 1 minus 1/2. I'm just rewriting. Now I have it ready to take the derivative. Okay, so I just rewrote my g of t. So I have g prime of t is equal to 2 times negative 1/2 is negative 1. So I have negative 1 t to the negative 3 over 2 plus 3 over 2 t to the negative 1/2. That's your derivative. How about tangent? Do we know the derivative of tangent yet? No. So we're going to rewrite it. So we're going to do sine of x over cosine of x because we do not know how to take derivatives of each of those. And we're going to use the quotient rule. So I do low d high, so the derivative of sine is cosine, minus high. What's the derivative of cosine? Negative sine, right? D low, all over the square of what's below. So when I do that, I get cosine squared x. Then I have negative sine times negative sine, so I have plus sine squared x. All over cosine squared x. Most important identity from pre-calc. What do we get?
1.
Cosine squared plus sine squared is 1, right? So I get 1 over cosine squared x. So how do you think we write this?
Sec squared x.
Yeah, 1 over cosine is secant, right? So I'm going to have secant squared x. That is the derivative of tangent. So do you think that you should memorize that one? You could do the quotient rule, right? You could, but it takes a lot of time. So the 6 trig functions, you should memorize. Okay, you should memorize their derivatives because it's going to save you a lot of time. So I'm not saying that you can't get a perfect score on the AP test without memorizing it. You're just going to lose some precious time, right, when you're doing it. So I remember when I was a senior in college, I went to a tutoring center and I was like, I'm going to just start tutoring here, you know, get some extra money. It's better than waitressing, I'll do this. And so I walk in and I hand them my resume and they say, oh, great, you know calculus, you're a math major? We need a lot of calculus tutors here, actually. So can you take a calculus test right now? And I was like, okay, I haven't taken Calc 1 since high school, but I'll go ahead and take this test right now. And I didn't remember those things. I knew them when I was in high school, like I had them memorized. But I didn't remember off the top of my head what was the derivative of tangent, secant squared, you know. So what I did is on the little test that they gave me, I just did it off to the side. I did the quotient rule for all of them and came up with what they were equal to, used my trig identities, right? And I did quite well. They told me that I was the only person that had ever taken that test and got it perfect. So I was very excited about that. But it took me a really long time. Like I sat there in that room forever because I forgot all of my derivatives. So don't do that. So don't waste time on the AP test. Know your derivatives. All right. So anyway, so I have g of x equals. So I'm going to do 2 over the 4th root of x. So I get 2x to the negative 1/4 minus 3 times sine of x. Do you guys want to hear another funny test taking story? Sorry. So my senior year of college, again, I had to take something called the praxis exam. So this is for any person that wants to be a teacher. I think in the whole United States has to take praxis. Might be Indiana. But anyway, so I had to take this thing called the praxis. And the first one that you take is super simple. So everybody takes it. People that want to be elementary school teachers, middle school teachers, high school teachers, we all take the same thing. So the math is super simple, right? It's basically like fractions. It's not hard at all. So the first test, you're not allowed to use your calculator. So I didn't take my calculator and I was fine. Did well on that. And then there's a second test, and that's based on your subject. So if you want to be a French teacher, you have to take a French test. If you want to be a math teacher, you have to take a math test. If you want to be a science teacher, science test, okay? So I had to take this math test, and I thought, oh, I'm not allowed to bring a calculator to the praxis. So I didn't bring my calculator. And then I show up there, and every single person in the room has their calculator. And I'm like, did I miss the memo? And they're like, okay, the test is going to start in like 5 minutes. And I'm like, oh my gosh. So I freaked out. So you have a couple hours to take this test, and I take the test without a calculator, but it's asking me things like sine of 13 degrees. And I'm like, I don't know. I don't know the sine of 13 degrees. So there's ways with calculus to approximate it. So I'm like trying to do this really, really fast, and I barely finished the test. And so I go home, and my roommates are like, how'd it go? And I'm like, I think I failed that test. I think I just failed the test to become a teacher. And so I get the results in the mail a couple months later. I'm like, oh my God, I do not want to open this. I just failed this test. And there was a certificate in it that said I had scored within the top 10% of all teachers that had ever taken that test. Isn't that scary? Does that tell you about the quality of education in the United States? I'm sorry. It does. Anyway, so I have g prime of x equals, those are my two stories. So I have 1/2 x to the negative 5/4 minus 3 derivative of sine is cosine. Now, a lot of people ask me, why do I not have to do the product rule when I have 3 times sine of x? So let's think about that. If I have 3 times sine of x, why do we not do the product rule?
Coefficient.
Yeah, because it's a constant, right? There's like a constant out front. It's just a coefficient. And you can pull constants to the front. Okay? If you did do the product rule, it would not be wrong, right? Y prime, you're going to have first times derivative of the second, so derivative of sine is cosine, plus derivative of the first is 0, and then sine is normal, right? Do you see how that part goes away anyway? So that's what happens whenever you have a coefficient up front. You can just pull it to the front and then take the derivative, because if you did the product rule, you'd get 0 for that second part anyway. All right, so the next one. Does it scare you that there's a theta? I never liked when there was a theta either. This is just like me asking you f of x equals 4 cosine of x minus x. Would you know how to take the derivative of that? It'd be negative 4 sine of x minus 1, right? Derivative of x is 1. That's the same thing. So f prime of theta is just going to be negative 4 sine of x, right? Or sine of theta, sorry. Minus 1. So the derivative of cosine was negative sine. So that's why I had a negative. Same idea. All right, so this next one. So it says find the equation of the tangent line at the point 0, 1. So choose your battles. Do you want to use product rule? You like all the rules. So you can write it as separate pieces and you can do the product rule. But what's easier? FOIL it out. So I get 1 plus 6x plus 9. Take the derivative. Oh, I was already ready to take the derivative. I was moving on to the next step. All right, so I get 6 plus 18x. All right, so my slope is going to be 6 because I'm plugging in x is equal to 0, right? So I'm plugging it in right there. Nope, it's 6 because 18 times 0 is 0. And then I'm going to plug in, so I have y minus y1 equals m times x minus x1. Now, I didn't have to write it in this form, actually, because you see that you have 0, 1. 0, 1 is the y-intercept anyway, right? That's your b. So you could have also just written it in slope-intercept, or in the, slope-intercept form. All right, and the last thing, so it says determine the points, if any, where the tangent line is horizontal. So when you see tangent line is horizontal, this will happen on your test a lot. What do you write? You want to find when the slope is equal to 0, right? Y prime equals 0. So we're going to do y prime. And I take the derivative, so I get 1 plus the derivative of cosine is negative sine. So I'm going to have 1 minus sine of x. I want to set that equal to 0. This is why I had to do all those trig equations at the very beginning of the year. Sine of x equals 0 means on our unit circle we have a y value of 0. So x is equal to pi over 2. Now, I asked for the points, though. So be very careful on the test. If it says find the points, you need to find the point. Right? That's the x value of the point. So we want pi over 2, and then we want to find its y value that goes with it. So how do I find the y value that goes with it? Plug it into the y equals equation, not y prime. What happens when you plug it into y prime? You get 0, right? That's why we started this problem. So I plug it into y. So I get y of pi over 2 is 1 minus sine of pi over 2. So sine of pi over, oh, sorry, I just told you not to plug it in there, and then I just did. I thought I had written my y. Okay, so I have pi over 2 plus cosine of pi over 2. What is cosine of pi over 2? 0. So I get pi over 2 plus 0, which is pi over 2. So my point is pi over 2, comma, pi over 2. That's it.
Is it always like that?
Where it's nice? No.
It's not,
They can be really gross.
because there was one in the homework that also.
Ah, that's nice. Nope, we're playing a game in a little bit, and one of them's really, really gross. All right, so y prime.
Would you get the second equation, the y of pi over 2?
I went back to the original, so I'm just plugging into the original.
Oh, okay.
All right, so y prime for this next one is 12x squared plus 3. Okay, so I'm trying to find where the tangent line is horizontal, so I'm plugging in 0 for y prime. Oh, wait, I made an error on this one. Make this a minus 3. Sorry. I changed that in the other class, but I forgot.
Well, then it actually works.
Yeah, I want it to work. Otherwise, there would be no points. You guys see if it was, because you'd have an I answer, so there would be no points where there was horizontal. And that could happen. You might have no points. All right, so anyway, so I get 3 equals 12x squared. Shh, guys. So I get 1/4 equals x squared. I take the square root of both sides, plus or minus. So I get x equals plus or minus 1/2. So now we go back and we plug in. So I'm going to find y of 1/2. So I'm going to do 4, 1/2 cubed minus 3 times 1/2. What's 1/2 cubed? 1/8 times 4? 4/8, which is 1/2. So I have 1/2 minus 3 over 2. So I get -1. What if I do y of negative 1/2? Then I get 4, and then I do negative 1/2 cubed minus 3 times negative 1/2. So I get negative 1/2 plus 3 over 2. So I get 1. Okay, so my 2 points are going to be 1/2, comma, negative 1, and negative 1/2, comma, 1. Okay, those are the 2 points. Does this make sense? All right, you guys can go on your break.